In this video, we're going to do our last topic of circle theorems, which is writing equations of tangents. Before we actually talk about the tangents, we're going to talk about the equation of a circle first. So a circle with a center at the origin with a radius of r has an equation of x squared plus y squared equals r squared. Example 1 says we have a circle that has its radius at the origin and has the equation x squared plus y squared equals 81. We want to know what the size of the radius is. So if we've got x squared plus y squared equals r squared is our general form. And now we're saying that instead of r squared, we have 81. This just means that r squared must be equal to 81. So if that's the case, we can take the square root of both sides to find out that our radius is just 9. Just a little reminder of something we learned last year. Gradients of perpendicular lines must multiply to make -1. Example 2 is just a little bit of a revision of last year's topic that we need to know in order to find the equation of tangents. So we're going to work out the gradient of a line perpendicular to the line y equals -5x plus 6. So in this equation, our gradient is -5, so we need to figure out the perpendicular gradient. We know that the perpendicular lines must have gradients that multiply to make -1. That means that -5 times our gradient equals -1. We can solve this by dividing by -5 on both sides. And remember that when you do a -1 divided by -5, we end up with just a positive number. So it's the gradient is equal to 1/5. Example 3 is another example of finding a line perpendicular to another line. And this time it's perpendicular to y equals 2/3 x plus 8. So our current line has a gradient of 2/3. We want the gradients to multiply to make -1. So we've got 2/3 times our gradient has to equal -1. To solve this, we're going to divide 2/3 on both sides. Remember, when you divide by a fraction, it's actually the same thing as multiplying by its reciprocal. So it's actually the same thing as multiplying by 3/2. So we end up with a gradient of -3/2, or you can think of it as -1.5. This key point is another example of something that you should already know. We talked about it a couple weeks ago, but the tangent is always perpendicular to the radius of the circle. There are 3 main steps to writing the equation of tangent. First, calculate the gradient of the radius. Second, calculate the gradient of the tangent. And third, substitute the given coordinate and the gradient of the tangent into y equals mx plus c to calculate the y-intercept. In example 4, we've got a circle that's centered at the origin, and we've got a tangent that touches the circle at the point P, which is 8/15. We want to find the equation of the tangent at P. So the first step is to calculate the gradient of the radius. Remember that the gradient is just the difference of the y values over the differences of the x values. So in this case, because it's at the origin, it's just going to be 15 minus 0 over 8 minus 0. So our gradient of the radius is 15/8. Step 2 is now to calculate the gradient of the tangent. To calculate the gradient of the tangent, we have to multiply the two gradients together and get -1. So that means 15/8 times our gradient is equal to -1. To solve this, you just have to divide by our 15/8 on both sides. And remember, when you divide by a fraction, it flips it. So our gradient is just -8/15. Step 3, we're going to substitute the given coordinate, which is 8/15, and the gradient of the tangent into y equals mx plus c. So looking at it, we've got 15 is equal to -8/15 times 8 plus c. We need to solve for that c value, so we're going to simplify the right side first. Because we have a -64/15, we are going to add it to cancel that out. So we're going to add 64/15 to both sides, and that makes it that we have a c value of 289/15. If you're unsure of how I got that, then you can post a comment to me, but it is just by simply changing 15 to an equivalent fraction with a denominator of 15. Now we can actually write the equation of our tangent by just simply using the gradient and the y-intercept in the y equals mx plus c form. So our answer is just y equals -8/15x plus 289/15. Example 5 wants us to find the equation of the tangent to the circle x squared plus y squared equals 169. at the point 5, negative 12. You can draw a diagram if you would like to for a visual, however you don't have to. The steps still stay the same, so we're going to start by finding the gradient of the radius of the circle. This circle is still centered at the origin, so we know that the x and y values for the other point will be zeros. So the gradient is just negative 12 minus 0 over 5 minus 0, which is just negative 12 over 5. So we can move on to step 2 now of finding the gradient of the tangent. We know our two gradients must multiply to make negative 1 because the tangent is perpendicular. So that means negative 12 over 5 times our gradient equals negative 1. We just have to divide negative 12 over 5 on both sides. First, if you're dividing by a fraction, it flips it. And also, if you have negative divided by negative, it becomes positive, so it's 5/12. Moving on to step 3, we're now going to substitute the coordinate 5, negative 12, and the gradient of the tangent into y equals mx plus c, and we end up with negative 12 equals 5/12 times 5 plus c. We're going to simplify it on the right side, and then we're going to solve, and we get c is equal to negative 169 over 12. Using our gradient and the y-intercept we just found, we are able to now write the equation of this tangent, so we get an answer of y equals 5/12 x minus 169 over 12. In example 6, we've got a diagram that shows a circle x squared plus y squared equals 17. It has a point P that lies in the circle and has an x-coordinate of 1. The tangent at P intersects the x-axis at R. We're looking to find the equation of the tangent. First step is to calculate the gradient of the radius. As you can see, we can't do this yet because we don't have the y-coordinate of our coordinate there for point P. So what we can do is we can actually draw in a triangle there and see that we've got one of the base is 1, and then the radius is going to be the square root of 17. Now that we're looking for one of the sides of a right angled triangle, we can use Pythagoras' theorem. Because it's not the hypotenuse, we can end up using the formula as y squared equals the square root of 17 minus 1 squared. Simplifying that down, we get y squared equals 16, which also means y equals 4. Now I know we have a coordinate of 1, 4, so we can calculate the gradient of the radius by doing 4 minus 0 over 1 minus 0, so the gradient is just 4. Next step is to calculate the gradient of the tangent. So remember, it's going to be 4 times our gradient is equal to negative 1. Then solve for m, and you get m is negative 1/4. Step 3 says, substitute the given coordinate and the gradient of the tangent into y equals mx plus c, and solve for the y-intercept. So we've got 4 equals negative 1/4 times 1 plus c. When you rearrange and solve, we've got c is equal to 17 over 4. Knowing that our gradient is negative 1/4 and our y-intercept is 17 over 4, that means our equation of the tangent is just y equals negative 1/4 x plus 17 over 4. That's all for this video. If you have any questions, then just leave a comment on Show My Homework and I will get back to you as soon as I can. Thanks.